If you own an Ender 5 3D printer, then you're probably already aware of what's the most annoying part about this printer, and that's that the bed drops all the way to the bottom at the end of almost every print. Well, I've shown you on this channel how you can fix this sometimes with G-code, sometimes with changing the firmware on the printer, but that doesn't solve against every situation. For example, if you have print recovery software built into your firmware or on an attached device, that's not going to work if the bed falls. So in this video, I'm going to show you how that you can fix this using a very inexpensive hardware switch out and one small change to your firmware. That's what we're doing today, right here on Kersey Fabrications. Let's go. So let's jump right into the fix for this problem. And to do that, let's first look at why are we having this problem to begin with. So if we look at the way that the bed moves, what we have here on the back is what's called a lead screw. The lead screw runs all the way from the bottom of the printer, where the stepper motor is, to the top of the printer, which is the maximum height of your bed. And what that lead screw does is it translates rotational motion from that stepper motor into linear motion of the screw. Now, how much does it move is determined by several different features of the lead screw. We have first what's called the diameter. The diameter is obviously how wide is the lead screw. The standard on most printers is going to be 8 millimeter. And then we have what's called the pitch. The pitch is the distance between each of the threads of the lead screw. Now that's not to be confused with what's called the lead of the lead screw. The lead of the lead screw is actually how far do we move linearly given one rotation of the screw. And for most 3D printers, we're going to have an 8 millimeter lead. That means we turn around one full time, we've moved the bed 8 millimeters. Now, there's one other number you may care about, and that's called the number of starts of the lead screw. And to get the number of starts, we simply divide the lead by the pitch, and we'll know how many starts, how many different threads that are going to be running around that screw. And if you look at this graphic I have put up here, you'll see that what changes here is that as we add more starts, as the lead increases, so does the angle of those threads. And of course, as those angles increase, then it's basically like rolling down a hill. If they're too steep, then the bed will simply roll down that hill, as it were. So how do we fix this? Well, we obviously are going to decrease the angle of that hill. And to do that, we put a lead screw on here that's going to have much less of a lead. Now the pitch is going to stay the same. And so what that's going to mean is that we're also going to have to modify our firmware here because our number of steps per millimeter are going to change. So later after the installation, I'm going to show you how that increased steps per millimeter not only translates into the bed not falling, but possibly is going to buy us increased accuracy of our prints. And we're going to actually test that when we're all done. First of all, let's get to swapping out the lead screw. And I'm not only going to show you how to swap this out, but I'm also going to show you a proper way to lubricate your lead screw before we ever get this on here, so that once it's on here, it's ready to go and you will have a longer life out of that lead screw. So now let's take a look at the actual lead screw that we're going to be using for our replacement. This is an 8 millimeter lead screw, that's the diameter, and it has a 2 millimeter pitch, just like our other one, but this one has a 2 millimeter lead, which means that it has a single start at the top. And as you can see, this nut does not move by itself. It doesn't want to roll downhill on this screw. Now, this is the default nut that this one comes with. This is one I purchased off of Amazon. I will, of course, include links in the description so you can buy the same one. But if you notice, take a look at this and listen. That is that lead screw vibrating. And it will create inaccuracies in your print, particularly if you use Z-hop. And more annoyingly for me, it also creates a rattling sometimes that you will hear in your printer. Now, how do we fix this? Well, there's what's also called an anti-backlash nut, and this one right here has a spring as well as a bottom piece that loads this – so that it doesn't shake on us. You hear this one. Notice no rattle because there's tension on this, creating a tighter fit on this screw. So I recommend not only to buy the screw, but to also get the anti-backlash nut to avoid any extra wobble in your screw, as well as to avoid the annoying shaking that you may hear if you use just the standard nut. So now let's move on to lubricating this screw correctly, and then we will replace it on our printer. Okay, so what do we need in order to grease our lead screw correctly? So first of all, we need to choose the correct grease, and I always prefer this white lithium grease. You can get it from different companies. I use the one by DuPont. This is white lithium grease. It has Teflon in it. And we're going to need something to cover our work surface. I like to wear gloves when I'm doing this so that it doesn't get on my hands. And I have, in this case, an old cotton t-shirt, but any cotton rag will do to clean up any mess or any overflow that you have on your screw. So first of all, let's take our lead screw. We're going to take our white lithium grease, shake it up, and then we are going to spray our lead screw. I'm going to do, you can just do two sides. It doesn't have to be totally covered. All right. Now that we have it sprayed, we'll rub a little bit of this on, some of the clumpy parts. And this is obviously going to be too much for our purposes, but we can clean that up after we've run our lead a couple of times up and down. So now I have my new anti-backlash nut. I'm going to put the head of the nut on there. And in order to put this on properly, you need to leave just this little notch on the top part hanging off the edge. I'm going to take my bottom with the spring already on it. I'm going to push it all the way down as much as I can, and then try to get it threaded on at the same time. And it may take a little bit of work to get it right where you want it. But once you have it on there just right, try to get it as tight as you can, but with a little wiggle room so that it still moves. Once that's on there, then what you'll want to do is run this nut all the way down your lead screw, and that will then allow us to clean up our mess once it's been thoroughly greased. Notice this is going to fall out of my hand a ton because it is slippery, which is why you are wearing the gloves to begin with. Okay, now once you've run that all the way up and down the screw, you can, maybe we should have put this on the other way, but nonetheless, run it all the way back down to a comfortable place where we're going to be able to reattach this to the bed. Obviously, you're not going to be able to reattach it if it's always at the top. And then we'll take our cloth, and I'm going to clean this nut off because we don't need all of this grease on the nut itself. But I'm not really going to wipe off the screw too much, because that will help protect and lubricate the screw over time. And as you can see, now that I've cleaned it up a little bit, this is ready to go. I'm going to set this aside, and we're going to take off the old one, and then we can put on the new one. Okay, so next up, we're going to remove the old lead screw from this printer. This is a pretty simple process. We're going to have two sets of screws we need to remove. First of all, we're going to need to remove these screws here holding the nut on, because we're going to be changing out that nut. So now that the nut's off, we need to remove the screw itself from this coupling. And there's going to be one screw down here holding it on. Now everything should be disassembled. Let's bring our bed up. This will make it easier. And we can pull, we're going to go up a little bit on the screw. And if I've loosened it enough, this will come out, and we can pull that right off. Now we take the one we just lubricated. I'm going to set it in the hole on the top, and then we'll set this back down in here. Now we'll come up here in a minute. Let's first attach this. To do this properly, I don't necessarily like it to sit directly on the axle of the motor. I'm going to actually raise it up just a little bit, and then I can tighten it. That just gives it a little wiggle room, as well as protects it from vibration from that motor potentially. Because after all, the whole point of the leads on here is so that this is not actually directing your plate, this is just controlling the motion. So at this point, the screws that came out of here will not go into this nut because these holes are not threaded. So what we need to do is create our own connection using an M3x12 screw and a washer and a nut, a lock washer particularly, if we have them. We're going to pull down on that spring before we put it on here so that the spring doesn't get in our way. Now, we can attach this directly to the plate. And don't tighten this down too far at this point. We need to get all 4 screws in before we do. Now, once all 4 screws are in, this should settle in there and not have much wiggle room, really no place to move it to. Now we can tighten all 4 of these down. There we go. And with the lock washers on there, this shouldn't back out. And we can double check that everything seems to move freely just by rotating that coupler down here at the bottom. So now that we're all done with the assembly, we can move on to the electronics and what we need to change in the firmware. Now, before we change anything, we need to know 2 things. Number 1, which setting are we changing? Number 2, what's the value of that setting? So first of all, what we're changing is the steps per millimeter of the Z-axis. And what that means is how far does the motor have to turn to equal a certain amount of linear motion of that axis. So let's do some math right here. First thing you need to know, what is the steps per revolution of the motor? All these standards NEMA 17s that you're going to find on Creality printers are 1.8 degree motors. That means that they're going to take 200 steps to go 360 degrees. So once we have that number, then we need to know what is our micro stepping set to on the printer. Well, these standard Creality boards are going to be set to a 16 microstep setting. So now that we've got 200, we're going to multiply that by 16. Now we simply need to divide by our new lead, and that's going to give us our new setting. So previously, if you do the math, you will find that our setting was 400 steps per millimeter for the Z-axis. Now what we've done here is quadrupled the number of steps that it takes to turn one resolution around. That's going to leave us with 1,600 steps in order to get all the way around to move 1 millimeter. That's our new steps per millimeter. So what does that mean for accuracy? What I mentioned before is now we're going to have a more accurate printer. So if you do some other math, you're going to find out that now we have gone from what previously was a 0.04 accuracy to a 0.01 millimeter accuracy. What that means is if you're familiar with what Chuck Hellebach refers to as magic numbers, our magic number has gone from 0.04 to 0.01. Now instead of stepping in those 0.04 millimeter increments, now we can do 0.01 millimeter increments and have a much wider range of settings. What that means is now those odd steps, those micro-stepped ones, which would have been in between, such as 1.0 millimeters, are actual physical steps of the motor that do not have to be micro-steps. Now this theoretically will result in better prints at all of those in-between numbers. Now we're going to test that here in a minute with 2 test prints. One that is at 0.2 millimeters per layer, and the next one which is at 0.1 millimeters per layer. The 0.2, of course, is at the 0.04 increment, while the 0.1 is not a 0.4 increment. That means that we'll be able to see, does that difference in stepping actually result in a better print? But first, let's get our settings into the printer. Now, there's more than one way to change the setting in the printer. First of all, you could do the display, which will take you through the control, motion, steps per millimeter menus, and then you can slowly crank up that dial to 1600. That's going to take quite some time, but it will work. You can do it the way I prefer, which is to actually go through some sort of console, either direct to USB or over your Octoprint interface. You'll go into the console and you'll be able to do an M92 Z and then that 1600. So M92 Z1600 will get you that setting, and then you can do an M500 to store that setting. So there we go. The mod's completely done at this point. We've changed out the screw, and we've changed our settings in our firmware. So now all that's left to do is our test prints. So what I've got here is the before test prints I did. I wanted to do something slightly different here because I think we all get tired of benchies and cubes and stuff like that. So I found another kind of benchy. This is what's called a Megalodon benchy, and I found this on Thingiverse. Of course, you'll get my links in the description. And I've printed two of these just like I said I would. I have a 0.2 millimeter height Megalodon benchy and a 0.1 Megalodon benchy. And what I'm going to do, I'm now going to reprint these same settings, same exact G code, but with my new screw and the new settings. Let's see if we see any difference in the quality of these prints. And of course, let's film the end of these prints to see if our bed falls when we're done or if it stays right where we left it at the end of the print. Let's get started. So there we go. That's the end of the print. The bed did not fall any more than what our G code told it to, which was 10 millimeters. And to verify that even further, I can move the print head back over the print right here. And if I come here into my menu and move that back up 10 millimeters, we'll see that it sits right back on top from where it ended. So there we go. Mission accomplished. And just to take one more look at this. So now I've gone in and disabled my steppers, and we're going to double check this. As I can push down on here. It doesn't even want to fall. It doesn't want to move just because I'm putting pressure on it. I can bump it. It doesn't move. It stays right where it's supposed to. So this looks great. Let's take a look at the quality of these prints. So all of my test prints are complete. Again, these are Megalodon benchies by a creator on Thingiverse named 5 Nights. I printed these at 125% size just to make them big enough to sort of analyze. And I printed them with Filament Once True Blue filament. Taking a look at these left to right. First over here we have our 0.2 layer height. And comparing the two side by side, I think the new lead screw might be better. And I say might, just because I think there's less artifacts on the print itself, but it's minor. So I would call this a minor upgrade, only comparing these two prints. Again, I don't have a huge sample set here, but I am trying to see, do I notice anything to the naked eye that's different? And going to our 0.1 models, again, there may be a marginal increase in quality, but I think I see it even less on the 0.1 prints. But there are a few less artifacts on this one, which is the new lead screw versus the old lead screw. And so overall, I think it is a slightly better print. Again, this is only a sample set of 4, 2 per lead screw, and so it's nothing scientific, but I think it's a marginally good upgrade if you were looking for accuracy. When Chuck Hellebach did this using his magic numbers video, he said that the differences in quality he noticed were more at the microscopic level, more with layer consistency if you look at it really close. I don't have a microscope to take a look at these, but you know, I think even subjectively at a macroscopic level, it's a marginally better print. So the point of this, of course, was to fix the dropping of the bed. If we get better accuracy or slightly better prints out of it as a result of the upgrade, that's just a big bonus. So that's it for this upgrade. I think this has been one of the easiest upgrades I've performed on this printer, and it may make the most difference to you if you're really tired of that bed dropping. Now, a couple of notes that I didn't cover before in this video. First of all, right after I installed the screw, I had some squeaking on that new screw. I'm like, is something misaligned? Is something not quite installed right? After simply taking the motors and running this up and down a few times, the squeaking went away by itself. It was just not quite lubricated correctly. If you still have some squeaking though, make sure your mountings are all aligned correctly down at the bottom of the printer so that it's not having to work any harder to turn that screw. Now, as with most of my videos, this video wouldn't have come together without some help from other YouTubers and some other people in the Ender 5 community. I want to send a big shout out to the Breadboard channel. Early on when I was learning about printers, his videos really helped me a lot, and I will link up here to his video on lead screws, and you'll see a lot of the math I covered there. Please subscribe to his channel. He's got some great content. Also, a big thank you to the Ender 5 users group, some of the members over there, as well as the Ender 5 Discord channel. They pushed me for this idea. I had looked around for this lead screw before, but they linked me directly to the part I was looking for, and that's why this one's finally brought to you here today. Final thank yous go out to my 2 new Patreon supporters since my last video. I have Bender Sama and Matthew joining me. I appreciate your support, and here's your shout out. So that's it for this video. Again, if you haven't subscribed, particularly if you're an Ender 5 user, click the subscribe button and make sure you click the little bell so you get my future updates. I'm going to have 1 or 2 more updates to this printer before I kind of set it aside just for a little bit, and you're going to see some new videos surrounding the Ender 5 Plus, which so many people have been asking for. So please stay tuned on this channel. I have a lot more coming, and I even will get back to my own project, the Cosplay 600. Again, thanks for joining me. I'm Chris. This has been Kersey Fabrications. Thanks for watching.